All right. And now we're going to start on a quick look at transistors, and we'll finish up with transistors tomorrow. I see lots of transistor failures, especially in power supplies and monitors and pinball machines. Very common. Much of the time, if you have a problem that's not a capacitor, you have a semiconductor failure, and transistors are real common failures. I see lots and lots of transistor failures. Transistors come in a wide variety of different shapes and sizes, different packages. You have 3 of those different packages, and each package has a different designation. The giant transistor that I gave you that looks kind of like that, not exactly. It's kind of, yes, this kind of guy right here. This transistor is known as a transistor in the TO3 package. That's transistor outline number 3 is really where that came from, the TO3 package. Commonly referred to as a power transistor, but it's really just a transistor in the TO3 package. Another one that I gave you that is no doubt familiar to a lot of you that have pinball machines is this package. This is actually called the TO220 package. TO220 package. Now, you'll note the part number of this part happens to be TIP31. This TO220 package was developed by Texas Instruments. TIP, Texas Instruments package. Anytime you see a part number that starts with TIP, it's probably in this TO220 package. And then last and least is this little guy here. This is the TO92 package. This is by no means the only 3 different transistor packages that exist. There are many, there are dozens and dozens of different types of transistor packages. And we'll see a couple of more, we'll see a couple of others later on. But these are the 3 most common. The only difference between these 3 transistor packages is the amount of current the transistor can handle. All transistors work the same way. They test the same way. The only difference between these guys is how much current they can handle. The bigger it is, the more current it can handle. Like the TO3 package can handle up to about 50 amps. The TO220 only 10 amps. And the TO92 only 1 amp or so. Maximum. This is maximum for each one. But as far as testing them is concerned, as far as we're concerned, as far as the specifications and all that stuff, they all work and do exactly the same thing. Basically, a transistor is just a switch. Really, that's all a transistor is. A transistor is basically just a switch, as we'll see as we go through this thing. Now, we do have 2 different categories of transistors, 2 different polarities. Some of our transistors are known as Npn transistors. Others are called Pnp transistors. Some are Npn, some are Pnp. Remember how the diode was made out of the type N silicon and the type P silicon? Remember that? Well, that's what it has to do with. Where the diode was 2 different types of silicon, remember type P and type N, the transistor is like a sandwich. Like an Npn transistor has type N bread and type P bologna, basically. A Pnp transistor has pumpernickel on each end and some non-specific food item in the middle, whatever that is. It starts with an N there. But that's how they get their names, NPN and PNP. And remember the diode had that 1 PN junction to test? The transistor actually has 2 that will test, and I'll show you how to do that in just a second. But because we have 2 different polarities, we do have 2 different schematic symbols for transistors. You don't have to turn there, but it's on page R1 or R2, I think it is. The NPN transistor looks like this. And you will usually see a circle drawn around these. I won't generally do it because I'm not much of an artist, as you can tell, and my circles never come out looking too good. But this is an NPN transistor. The Pnp transistor schematic symbol looks basically the same, except that the arrowhead points in toward the center of the symbol instead of pointing out. It does not make any difference which way I draw the symbol. The thing that you can use to tell the difference between them is if the arrow points out, it's NPN. If it points in, it's PNP. In other words, if I take this NPN transistor and turn it 90 degrees, the schematic symbol looks like this. The arrow still points out. If I take and I flip it upside down and put the arrow on the top, it will still be pointing out. Same thing with the PNP. The reason I draw them the way I do on the schematic diagram on the board here is that is the arrow on the top here and on the bottom here, is that in a schematic diagram, electric current flows from the top of the schematic down to the bottom usually. And it flows, just like through a diode, the way the arrow points, it flows through the transistor following the arrows. That's why I draw them the way I do. And you'll see more about this as we go through it. But you remember that the diode had names for the two leads. Remember the anode and the cathode. Well, the transistor leads also have names. The lead with the arrow on it is called the emitter. E-M-I-T-T-E-R, the emitter. As the name implies, it emits something, and what it emits is electrons, actually. On the same side as the emitter is the collector, collecting what's emitted by the emitter. Again, specifically, it's electrons. And then over here on the left-hand side, all by itself, is the base of the transistor. So the transistor has three leads: the emitter, the collector, and the base. PNP, same thing. The base on the left, the base, as they say in Mexico, the emisor, the emitter. No, it's actually E-R. And the collector. The emitter, the collector, and the base. Let's start off by taking a look at the NPN transistor first, because we see more NPNs than PNPs. Basically, a transistor is just a switch. That's all it is. A transistor is just a switch. Here's how it works. In a transistor, the main switch is between the collector and the emitter. The main contacts, if you will, are between the collector and the emitter. When the transistor is off, there is no connection between the collector and emitter whatsoever. None. When the transistor is turned on, the collector is connected to the emitter inside the transistor. When it's off, there's no connection between the collector and emitter. When the transistor is on, the collector is shorted to the emitter. Not shorted, destroyed, ruined, but I mean just connected inside. The base is the controlling element of the transistor. The base is the thing that controls it. All we have to do is put a small amount of voltage on the base of the transistor, and it will turn it on and connect the collector to the emitter. Gee whiz, guess how much voltage it takes on the base of the transistor to turn it on? What numbers have we used so far? 0.7. Right. Remember that 0.7? Remember I said it takes a certain amount of voltage to operate the diode, that junction drop? Same thing with transistors. That 0.7 is like a magic number that we get to again and again and again. That's 0.7 of a volt, because that's how we turn the transistor on. All I have to do is put 0.7 of a volt on the transistor, which is an itty-bitty amount of voltage, isn't it? And the collector and the emitter connect together. Here's the easiest way to think of the transistor. Think of the transistor as a wall switch like this one over here. This is the base. This is the base. The toggle, the thing that you touch, is the base. And you know that on the switch, there's a couple of screws over here on the switch, right? When the transistor is off, there's no connection between those two screws at all. That's like the collector and the emitter of the transistor. It'll come off. I did this once. I had the wrong kind of pen. I had one of those Marks-a-Lots that don't come off. But the base is like the toggle. Does it take very much energy for me to do this? No. It takes very little effort to hit the toggle, the switch. And yet when these two screws on the side are connected together, just like the collector and emitter, I can be controlling thousands of watts of power. Not just the insignificant little light here, but I can be controlling a lot of power that way. So it's the same thing with transistors. When you think of a transistor, just think of it like a toggle switch here with the two screws. There's the collector, there's the emitter, the toggle is the base. When the transistor's off, there's no connection between the collector and emitter. All I do is flip the transistor on by putting 7/10 of a volt on the base, and those two guys are connected together, and that's all there is to it. Very, very simple. To be quite honest with you, it doesn't make a lot of difference if you understand how a transistor works. The most important thing you can learn is how to test it to see if it's good or bad. And you'll find that that's how I'll be working things this entire class. As we go through this class, you'll see that I personally don't give a rat's ass if you know how the thing works, as long as you can fix it. And that's what we're going to be going through here. So let's take a look at the transistor test and see how we test the transistor. Turn in your blue book to page 10. In order to test the transistor, you do have to know which lead is which. You have to know which lead is the emitter, which lead is the base, and which lead is the collector. If you look at the TO3 package that I gave you, that's the big one, the TO3 package. You see that there ain't but two leads sticking out of this thing. In this particular case, they're labeled, but they aren't always labeled in all these transistors. These leads, if you hold it if you hold it right side up so you can actually see on these particular transistors, the little leads there, and the one on the left is the emitter and the one on the right is the base, right? The collector is the case of the transistor. The metal case of this transistor is the case. For that reason, whenever you see one of these transistors mounted on the side of a chassis or on a metal heat sink, and we'll talk more about heat sinks. Well, I can show you a heat sink here. Wait. Here's a couple of them, in fact. If you look on this metal thing here, this finned aluminum thing is a heat sink, it's called. Transistors don't like to run hot, and that's why they're mounted on this heat sink. Whenever you see transistors mounted on heat sinks, you'll see these insulators mounted behind them. You don't mess these up. I'm just going to pass them around so you can look at them. I only have 4 of them here, so be careful with them. These are made out of mica. They're fairly delicate, so don't screw them up. Because the collector is the case of these things, it's electrically active. It's going to have some voltage on it most of the time. Can be anywhere from 12 volts to 160, so depending on what the circuit is, so be careful. You will always see one of these insulators mounted behind it. You'll see an insulator mounted behind it like this. When you change the transistor, you must make sure that you put the insulator back. You don't necessarily have to replace the insulator and put a new one in as long as it's intact. Also, very important word of warning. Sometimes you'll see some white goop on these things. It almost looks like the transistor leaked out some white. It looks like toothpaste, exactly like toothpaste. It doesn't taste like toothpaste. So this white goop, it did not come out of the transistor, although the transistor is filled with the same stuff. There's this stuff that they put on transistors called heat sink compound. You'll probably see it on Wednesday when we pull the power supplies apart. This heatsink compound is put on the back of the transistor and also on the heatsink, on the insulator and on the heatsink. It's used to help conduct the heat away from the transistor. It's not electrically conductive, just heat conductive, thermally conductive. Caution, warning, danger, Will Robinson. Don't get this jazz on your pants. Once it gets on your clothing, you just can't get it off. I don't know what the hell this stuff is made out of, but if you get it on your pants or something, you won't get it off. So when you get this on your hands, don't go, like this. It just, unless you don't care. I mean, if you're wearing work pants, no big deal. Might improve them, but be careful about that. When you see it, it doesn't mean that your transistor exploded or anything. That's perfectly normal. People put that stuff on. You're supposed to put new heatsink compound on whenever you change a transistor. I don't do it because I was trying to be very professional for a while, and I carried a little tube of it around in my toolbox till my long nose pliers skewered the tube and got this white crap all over my tools. I'm sure whoever stole my tools still has that white crap all over them because I couldn't get it off or shit. So anyway, so be aware of that. Now, even though it's printed like this, the way I normally think of this transistor, because you do have to know which lead is which, the way I normally look and tell which lead is which is that if you look very carefully, if you draw an imaginary line dead center in that transistor, you'll see that those leads are not right on center. They are slightly offset, aren't they? You look at it carefully. If I hold the transistor so that the leads are slightly offset above the center line, they're in alphabetical order. Base is on the left, the collector is the case, and the emitter is on the right. That's the way I remember it. You're not going to be able to see the bottom of these transistors because they're mounted on things like this. You can't see the bottom of that transistor without taking it off, but you want to be able to test it without pulling it off. You get what I'm saying? So the only way you can tell which lead is which is look at it carefully. Those leads are not right in the middle. They're just slightly offset. And if you hold it so that they're offset above the center line, alphabetical order, base, collector, the case, and emitter. The TO220 package, extremely easy, alphabetical order. Base, collector, emitter from left to right. B, C, E. Also, very important, in the TO220 package, the center leg is connected to the metal tab on the top. These are electrically the same point, meaning that the metal tab is electrically active. It is the collector as well. And again, when we open up our power supplies, you'll see that there's an insulator behind these things as well. There's a small insulator that goes behind these transistors as well. So BCE, alphabetical order. Now, the little dinky one I gave you, unfortunately, is not standard. The TO92 package, remember this is TO220, TO3. The TO92 package changes depending on where the part was manufactured. In the United States, and this is the way you'll see it from the bottom, you're now looking at the bottom of the transistor, looking up that way. It's emitter, base, collector. That's in the USA. But depending on where it's made, it'll be a little bit different. Do not write this down what I'm about to show you because I can never remember this. One of them is BCE and the other one is ECB, and I can't remember. One of these is Japanese and the other one is European. The reason that I can't remember is that it's silkscreen on the board. The reason I can't ever remember is that it's silkscreened right on the board, and the board tells you which lead is which. For instance, you see here a bunch of these little transistors. You can see them all over the place. This really nice clean monitor. Well, on the bottom side of it, it tells you which lead is which. For instance, you see the little E's and B's and C's that are in the circles there? Here's transistor X304, transistor number 304. Here's the emitter lead. Here's the base lead. Here's the collector lead. You know, here's another one. They're all over the place. Here, let me show you another one. Here's X104. See, E, B. Here's another transistor, emitter, base. You know, they show it to you all over the place. Here's another one. Here's X402. Looks like it's been changed or tested. Collector, base, emitter. So this is pretty simple, really. That's why I can never remember which one's which, because I never have to. You know, if I don't have to memorize something, I'm sure as hell not going to do it. That's for sure. So I got enough stuff to remember anyway. But these are always the same.